So hello and greetings to the all the viewers. Today we will talk about how to generate and study FEA report in ANSYS Workbench. Most of us don't know that ANSYS also gives us automated FEA report. So whatever the simulations you are performing, that simulation will be recorded within the ANSYS system. So in this presentation we will try to study how to extract that FEA report and how to use for your respective work. So this slide represents the learnings in this video. The very first we will discuss about this cantilever beam simulation. So in this we will try to model this and we will apply a point force over here and we will fix one end. So here we will try to model this cantilever beam and we will perform the FEA simulation. And for this respective FEA simulation we will study how to generate automated FEA report, as well as we will study how to read and use that respective FEA report. And also we will see the changes in FEA report with multi-step analysis, if any. So what we will do now, we will move towards our ANSYS module and we will start our simulation. So now if you see, we are in the ANSYS Workbench module. So here you just need to simply drag and drop from analysis system this static structural module. So here before starting the simulation you just need to cross check the units from this, whether you want metrics or you want US customary units, and you just need to right click and edit in a geometry in design modeler, or also you can double click so that your design modeler will going to open. So now what we will do, we will model a simple cantilever beam here, rectangular cross sections, and from here also you can change the unit system. I will keep that 100 by 100 and I will try to extrude this section up to distance of 750. Okay, or even if you want we can reduce that up to 500, but it seems to be quite smaller. Now our geometry is ready. Now we will move towards our mechanical window. So now we will do simple cantilever beam point load simulation for 100 into 100 rectangular beam. So now I will just very fast apply a fixed support at this point, right? And we will apply here, insert, right click. You can right click on this and go to insert and you can select the force, or even you can right click here, insert force from this. Okay, now if you see here you can select the geometry and here define by components, and we need to apply in negative y direction, so that's why I'm putting this minus 10,000. Okay, now I will try to solve this. I'm not focusing on meshing and any other details because here we need to study the report, automated generated FEA report. So now if you want to see the mesh, you can see it seems to be good mesh, 3 millimeters across the your width and height. So now our solution is in progress. Now I think the solution is performed. So now if you right click here, insert deformation plot, so you can easily find out from this the deformation pattern, right? If you want you can put more scale 100 and check deform and deform wireframe, and also if you want you can check the animation. Okay, Now it seems to be our simulation is performed. Now if you go to here in this window, you will find at the bottom there are three tabs. Like first one is geometry, second one is print preview, so it will gives you a print for that respective image, and third one is what we are looking for, report review. So if you click on that, it will automatically generate your FEA report, okay, from this report preview. Now whatever the simulations we had performed, all are captured within this video report. So here if you see, it will first show the ANSYS logo, and then it will show us when we had saved this file as well as product version, okay. And this is what your basic geometry file you will find, and if you click here, it will shows the contents. Then after, and within this contents you can find the unit system, you can find the model depicts our geometry, solids, if any shells or if any assembly, it will show within this tree. Then is there any cross section, it will show the cross section over here, and also the coordinate system, mesh, static, structural. So what are the things we need to do for a FEA simulation? Most of the things are written over here. In addition to that, if you see here, material data are also provided. If you click on this, it will go to your structural steel table. We know that by default ANSYS uses a structural steel, so you can find here the density, coefficient of thermal expansion, specific heat, thermal conductivity, resistivity. So all these properties are all written in this report, okay. And other than that, we will check one by one, like geometry. In the geometry you will find the details like object name, states, source where you have saved this file, the type like either a design modeler, then it will also depicts the unit system. In addition to that, it will also shows the bounding box. So from this you will get an idea of your respective object size, whether it is 100, as we know that we had considered 100 into 100 by 750. So all this you can find out from this bounding box, and also it will depicts you the volume as well as mass properties, right. And also it will depict the number of bodies and nodes as well as elements, so within the geometry table itself. So no need to go to mesh and go to static. Here statistics, you can see here, you can easily find out from this report review the number of elements as well as number of nodes, okay. See, we will further go to that. I will click on a geometry, right. It will show the number of nodes. You can see it's matching with our elements. Then after the geometry table, you will also find the another parts. Based on your parts, it will also show the for respective part elements, and even your moment of inertia, your CG coordinate, you will also find out from this. We know that we can find out the CG coordinate from design modeler, from mechanical, as well as you can find out within this report preview, okay. Then it will also further depends the any cross section is there. If you had used any cross section, it will also shows us here. You can see this breadth and height, okay. And then later on it will also show the global coordinate system, or if any local coordinate system which is present within the simulation. So you will find here x, y, z coordinates for your respective geometry, and also it will depicts you the Cartesian coordinate system. Then next it will show the further the mesh table. Within this mesh table, it will show us the sizing controls, whatever the global sizing controls are there, you will find over here. So no need to go this, and you can check. It's better you can check in the report preview itself. So we can see the physics reference like mechanical size function is adaptive, relevant center, course, okay. So all the major FEA details you will find from here. Also if you have kept it the mesh quality on or not, you will find from here the targeted quality. All these details you will find within this report preview. And also you will find there are some, if any inclinations you had used it will gives all the details within your system for a respective mesh. Then later on it will move towards the static structural, and within this static structural it will also depicts us the analysis type, whether you had used structural model or you have used any thermal, steady state thermal, or other models. It will depicts here within the static structural tab. Okay, now you can also check your environmental temperature, means reference temperature. And also if you see here with this analysis system already capture within this FEA report. So we had used number of step 1, we had applied a force, and it showing the respective settings for each and every load step. Right now we have only one load step, so you can see number of step 1, step end time, auto step timing, and if is there any weak spring is on or off, also score release effect. These are the rotodynamics or other controls. So all the controls you will find within this report preview. Okay, now also it will show the solver directory and all other settings which you will find within this output controls or within this analysis setting tab. Okay, so no need to go here, you can easily find out from this report preview. Now the next one, you can see the geometry phase where you have applied that respective forces. It's showing the type, fixed support, as well as whatever you applied that force based on the IT. It is showing like you had applied a boundary condition as a fixed support and loading as a force. So all the details are already present here. Now you can also see the figure showing, like if you go to geometry, it will show you the within the graph, like you had applied from 0 to 1 the force of 10,000 Newton. Okay, now also within a solution tab it will show you all other controls, and here also it will show you the solution information, FEA connectivity. So all the details are already present over here. Now what we will do, apply, we will go to further geometry. Now this is what the graph you are showing, you are viewing on the report view. I will do one thing, I will apply a force in a 2 load step. In first load step, okay, we will apply Control C, Control V. So you can find the force, and now we will see if any changes in the report review or not. It should capture the changes in a multi-step. It should capture all the details further. Now if you go to further here, geometry, and then report preview. Now it is generating the report. Now we will go to simply the loads. Now if you see in the loads, it's showing fixed support forces. Okay, now you can see the graph like 0 to minus 10,000 in load step 1, and then it's gradually increasing from 10,000 to 50,000 in load step 2. Now you can see here in load step 1 whatever the force we had applied in negative y direction. Similarly for load case 2 we had applied a force of 50,000. So the advantage of this report preview is you can easily do the QC, quality check, for your FEA simulations from this. No need to check each and every details from design modeler as well as from ANSYS mechanical window. So you can simply cross check here all the details, and then if you found any errors, then you can easily correct. Okay, so it will save your time, and also you can utilize the graphs as well as some of the tables from this system. Okay, now what I will do, I will go to geometry and I will do some changes further. Here I will right click, insert construction geometry. So I will try to capture a simple path at the middle section. Insert path. So for this respective path I want to see the equivalent stresses. Okay, evaluate all results. Now you can see here for this respective path whatever the stresses are present. So let's see if it is captured within the report preview or not. I will further clicking on report preview. It's generating all the details. Once it is done, you just go to further your static structural and just simply go down. Okay, so now you can see here your graph. So if you are doing simulation like pressure vessel, in that case we need to do the stationarization. So for that we need a graph, so you can easily capture that graph from this. Okay, like, and if you are going here, I want membrane plus bending, I don't want total, so you can click, go to report preview. It will further show you the, see, so you can easily find this membrane and membrane plus bending graph from this report preview. Also you will find a table, so it is very useful for the pressure vessels or any simulation where we used to do the stationarization. So you can easily see what are the bending as well as membrane plus bending and peak stresses. Okay, and also you can find out the material details. If you are changing any other material, I will further go to here. I will use some of the material from engineering data. So now if you want, you can use another material, like I will going to use aluminum. Okay, I will further refresh, go to setup. Now I will just simply change the material aluminum alloy, and let's see whether it will reflect in the report or not. So you can easily cross check from the print report preview all the details. I think it first it need to go to geometry, further into report preview. So now you will find the further aluminum alloy details. See here, isotropic elasticity, in all the details you will find here. Density for aluminum, coefficient of thermal expansion, specific heat. So likewise you can use this FEA report within the system which is generated by ANSYS itself. It will be more useful when there is a complex simulation, multi-step simulation, and when you are using a more number of parts, or you can say the geometry assembly, and also if there is any contact between the bodies, it will also depicts the different contacts within the system, so that you can easily cross check. So what we will do, we will go to further here. I will simply go to create body operation, translate. So let's see if any it will depicts us a contacts or not. So I will put here 100, like 510. Okay, our 750. Now I will keep a gap of 5 mm or keep a gap of 10 mm. Generate. Okay, now we will go to mechanical. We just wanted to see the contacts, whether it will reflect the contact within system or not. So what I will do now, I will change one as a structural steel and another is a aluminum alloy. Now we will go to connection, insert contact, manual contact. We'll now select the both the faces here, very first, and another over here. Insert contact tool. Let's see, first generate the contact tool whether these are close or not. Okay, now the contact says that it is close. Then what I will do, I will keep force here and I will fix, stop this face, I will fix this face. Now let's see if it will depict the contacts. It will take some time. Okay, our solution is done. We just check the behavior. That is fine. I will go to solution and here report preview. Now it is generation is in progress. Okay, so if you see here connections, contacts, so it will also depicts the contacts which you had used. Okay, so like you will find auto detection, yes, transparency in all these things. Even here it will show you the contact, whether it is face to face or with is solid to face, like that it will show contacts from solid and one face is already selected, similarly like that it will show, and also the contact type. So you can easily review the number of contacts, you can easily do the QC for that respective contacts. Okay, so that is what the use of this automated generated FEA report from the ANSYS. The next thing, that how to save this. So you can do like, you can simply control P and go to Microsoft Media print, then you can save this FEA report auto. Okay, then we will try to open that. So you just simply right click over here and open that your respective report, and if you go to down, you will find the same content what you find in a ANSYS Workbench module. So it is nothing but the printout, or it is nothing but the PDF file of that respective FEA report. Okay, so likewise you can save that from your ANSYS. Just you need to simply control P. So that's it guys. So basically the purpose of this video is to show you how to generate the auto FEA report and how to utilize. So you can utilize from this, if any linearized stresses, you can easily capture that. You can use this image within your FEA report, you can use this table for your FEA report, as well as you can do the QC for your complete FEA, like from geometry, your contacts, your mesh, as well as your analysis settings. So all the details will be present within this FEA report. So thank you guys, let me know your comments, I will be there to help you.